All right. Algebra 1, folks. Thank you for hopping in to our lesson today. Very excited to get our first lesson of 2021, your direction and into your hands. Brand new unit here. We're going to be talking about functions. This is going to be a word that we're seeing and referencing and learning a lot about over the next 3 to 4 weeks. I'm going to start off with the definition here, right off the rip. Okay. It says a function is a set of ordered pairs listed as xy, like those coordinate pairs we've seen before, in which each x value is paired up with only one y value, okay? Meaning, another way to say it is every x has only one y, okay? Before I start throwing some math examples your way, I want you to think about this a little abstractly here. So thinking about it as a vending machine, okay? So I want us to just be creative and use our imagination here, okay? Think of a function like a vending machine. First thing we do is we put our money into it, right? A vending machine's never going to do what we want it to do if we don't put money into it. So our money goes in. What do? Okay, we don't just stare at the machine. We push a button. For instance, we'll say B6. We push B6. Out comes a specific item, right? Candy, chips, a drink, something like that. Our expectation is that what comes out of that machine is the button that we push, right? We push a button based on the item that we want, and the item that we want comes out. That means that machine is functional. It is working. We pushed one button and out came the item that we wanted. B6 gave us Skittles. I put in another dollar. Let's say I push, G2. Out comes a bag of Doritos. I'm getting what I want. That machine is functional. Think about what it means if I say that is not functional. If I say, hey, this vending machine is not functional at the moment. All right, what we're thinking is, well, it's broken. How might it be broken? Well, an example might be I go back and I push, the first time I pushed G2, I got Doritos, right? If I put another dollar in because my friend wants Doritos, I push G2 again, but this time I get Mike and Ike's, right? That machine's broken. It is not functional. That is a broken vending machine. This function, it's not a function, right? Things in math can be a function or not a function, just like things in the real world can be functional or not functional. If it's functional, it works. It works every time. Every one button on the vending machine gives me one item. If it's not functional, that one button might give me different items when I was expecting something else. Okay, that's kind of the abstract thinking I want us to use there. And I'm going to take it into some math examples below. Okay, so we're going to see down here, I reiterate again. You're going to see here, it says, again, a function. I can't stress this enough, this unit. A function is a set of ordered pairs in which each x coordinate is paired with only one y coordinate. Okay, in a list of ordered pairs belonging to a function, no x coordinate is repeated. And I'm going to explain that in these two examples below. I'm going to kind of hop down to this machine here, and I'm going to reference this problem up above. Okay, so here's more so. Now we're not looking at a vending machine. I want us to think more of a math example here. So I have this here, this box, and this box is our function. No more fancy vending machine. Things go into this function, right? We put them in. Okay, in this case in math, x is what we put into the machine or the function. Okay, what comes out is our y, and those have specific names that I'm going to start using that I want to be a part of your math vocabulary. The things that we put in are called input values, which makes sense. We put them in, they're called inputs. Well, then what comes out? They're called outputs, right? So what I want us to start thinking about is that x is always my input and y is always my output. And then this function is what's happening, right? Something is happening in this machine. Okay, our vending machine, some kind of code was happening. It took the arm of the machine. It pushed out the item that we wanted. I'm going to give a very, very basic example of a math function. I'm going to say in this machine is doing +3. Okay, and what that means is I'm going to drop an x value or an input value into this machine. The function is going to do +3 to whatever I put in, and out on the other side is going to be what I put in +3. Here's an example. So I'm going to put in the number 5. 5 is my input. I put 5 into this function. My function adds 3 to it. What should come out? Well, what should come out is 8 because 5 plus 3 is 8. In this same function, let's say I put in another number. I'm going to put in a 10. 10 is my input. My function does its thing. What should come out? Out should come 10. Excuse me, 13, because I added 3 to that function. One last number. If I put in -7 into this function, and I that's my input, and I add 3 to -7, I get -4 comes out because I added 3 to it. Okay, over here on the right, it says, right here, I'm reading this. If you are given an x value belonging to the function, you can find the corresponding y value. That's what we just did. We were given x values. I made them up. We put in the numbers -7, 10, and 5. Our function did what the function was saying. Our function said +3, okay? And then out came the corresponding y values. It was just, hey, take your input, add 3 to it, and it comes out the machine 3 greater than it went in, okay? And there's lots of different things that a function can do. +3 is very basic. It can multiply, it can divide, it can subtract, it can multiply and add, it can divide and multiply and subtract. Exponents are involved. Parentheses can be involved. There's a lot of things. Functions can get very multi-step, or they can be very basic. You'll see both kinds as we learned during this unit. Okay, so I'm going to kind of reference this up here, this example. It says you can use a table to represent a function. Suppose you read a book at a constant rate of 50 pages an hour. It says the number of pages you read can be described in terms of the number of hours you read. Okay, so what this is, in our example, is this elapsed time, which just means how much time has gone by, is like our x, and our pages read is like our y. Now, we don't get this wonderful picture of this machine here, okay? You just have to start getting into kind of a thinking mode of, I don't see the picture of the machine, I don't see a picture of the function, but it's there, okay? What is happening in this function, the number 1 was put in, and the number 50 came out, okay? Look at this next one. Our input was 2 hours, and our output was 100 pages. Okay, our input here, 3 hours. Our output, 150 pages. Our input is, our input is 4 hours. Our output is 200 pages. The same thing is happening. Imagine that I really have, right? What I want your brains to start thinking of is here's our x, here's our y, like we see there, right? This is the pages, this is the time, and then here's the actual function, right? What's happening? I put the number 1 in and I get the number 50. In this same function, in the same machine, I put in the number 2 and I get out 100. I put in the number 3, I get out 150. I put in the number 6, I get out 300. The only way I can take those inputs and get those exact outputs is if my function is saying times 50, right? I put in 1. 1 times 50 is 50. I put in 4. 4 times 50 is 200. I put in 5, right? I put in a 5 there. 5 times 50 is 250. We don't get the pleasure of having this function drawn for us in a space or an image, a machine like this or a vending machine. But a function in essence is something, is a mathematical problem that's receiving inputs, it's getting things put into it, and it's shooting out outputs, and it's doing the same math over and over if it is a functional function, if it is truly a function, okay? So we have down here below just this little note based on that example above. When my input is 5, when I put 5 into that function, out comes 250 pages because we were told we read at a rate of 50 pages an hour, okay? Just kind of a mindset I want you guys getting in. There's a function. You're not going to see it. You need to think about it, what's happening in that machine, like that vending machine. It's taking something, it's spitting something else out. What mathematically can be done in that scenario, okay? Moving on here, down below, okay? A couple quick ways to tell if something is a function here is kind of this next topic here. It says, how can I tell if something is a function or not? One way we can see is just looking at ordered pairs, which I mentioned above, right? An ordered pair is x, comma, y. And what I want you to start thinking of, again, you don't ever need to draw this, but your mind should be thinking this way. I have x, I have my y, and then something here, the function is in between. It's like passing through here. And math is happening in this space. Again, it could be addition, subtraction. Those things that I listed before, it could be multiple, it could be multiply, then something as basic as like times 2 plus 1. Okay? It can take a number, multiply it by 2, then add 1, and it spits it out, and that's your corresponding y value. But I can look very quickly at these ordered pairs and answer a question, is this a function or is this not a function? And all I'm looking for is, does every x have only one y? It needs to be paired up with its own y. I'm going to say that again. Does every x have only one y? Let's look at this first example on the left. The question is this set of ordered pairs a function? It's wanting to know, hey, these 3 ordered pairs that are all listed to us from the same machine, is it a function? Well, let's just take a look. Here's my x and my y. Here's my x and my y. Here's my x and here's my y from 3 ordered pairs. The first thing, 0 is plugged in as an input and out comes a 4. That's not enough information to figure out, so we need to keep looking. Now, next we get plugged in a -2, which is different than this one, and out comes a 2. So again, everything right now is telling us, hey, this is a function. We get to this third order pair. A 0 is plugged in again, right? 0 was plugged in the first time and out came a 4. Now a 0 is getting plugged in and out came a 0, right? So ding, ding, ding. Something should be telling us, hey, this is not a function. I put a 0 into this function the first time a 4 came out. I'm putting that same exact thing into this function and a new output is coming out. Think of that vending machine. If you press 0 and you get a 4, right? If you press 0 and you get a bag of Skittles and I go the next day and press 0 and I get a Pepsi, that is not a function. That is broken. You're probably annoyed. This should be telling us, hey, just based on looking at these ordered pairs, when I plug in, I'm going to get rid of some of this, right? When I plug in the same input twice and I'm getting out 2 different outputs, a 4 and a 0, hey, that's not a function. We would say this set of ordered pairs is not a function. And that's as simple as that. We can say, hey, that machine is broken. It's not a function. If it was a function and I plugged in a 0 again over here, the 4 should come out just like the first time it did. Okay. Let's take a look at this second example over here. It says, asking same question, is this set of ordered pairs a function? I'm just going to go through this list. Now we have 4 ordered pairs instead of 3, and that's totally fine. Sometimes you'll get 4, sometimes you can get any amount, but we're just going to look. Here's 4. I plug in a 5, out comes a -1. That's business as usual. Okay. We don't need to think about what's happening in the function, right? That could be -6. It could be times negative times -1 minus. There's a lot of things that it could be doing. Plug in a -3, out comes a 4. These are different. 5 and -3 are different. I don't have to worry yet. I plug in a 0, out comes a -1, and I plug in a 2, out comes a 7. Okay, right now, based on this information, okay, we are saying, hey, that is a function. And I want you to take note of this. It says 2 ordered pairs, this pair, so our first one, and our second one, okay, have different x coordinates but the same coordinate for y. This does not prevent the set of ordered pairs from being a functional relationship. So this set of ordered pairs is a function. So think about this, right? You might be thinking, well, 0 was repeated over here, and it had 2 different outputs, so it wasn't a function, right? So now we're saying, hey, -1 comes out twice. Think of that vending machine again, right? If there's a very popular item, right, so I'm going to use, we'll say Sour Patch Kids. If it's so popular, the vending machine might make it so that B3 and G2 both have Sour Patch Kids. If I push B3 and I get Sour Patch Kids, and I go push G2 and I also get Sour Patch Kids, that doesn't mean the machine's broken. That means they have that output on 2 different buttons, right? So back to this math example. Just because I put in 2 different things doesn't mean I can't get the same thing out, right? A math example of how can I get from 5 to -1, where I could also get from 0 to -1. If I do times 0 minus 1, 5 times 0 is 0, and 0 minus 1 is -1. Same thing up here. 0 times 0 is 0, and 0 minus -1 is -1. That is okay. So we are just making sure, does every x have only one y is the biggest piece. We're not saying does every y have only one x. We're saying does every x have only one y, okay? We're going to kind of stamp that statement down here. As long as each x value has its own unique y value, then it is a function, okay? Very straightforward. So we can look at ordered pairs like these 2 examples and tell very quickly it's a function or it's not a function. We can answer that question, which is pretty cool to be able to do that quickly. Okay, the second thing we're going to look at here is sometimes we're given a graph, okay, with some points on it, and it's asking the same exact question, okay? That question being Do the ordered pairs graph below represent a function? If you think what we just did above is pretty easy and straightforward, this really turns up being the same problem. I have 4 points here. I have this one. I have this one. I have this one. I have this one. I can just list those ordered pairs, right? I know how to find out where each of those points is. We'll call this one point 1, this first one here. That point is at -1, 4. I'm going to list the second point here. That second point is at, that looks like it's at 3, 4. The next point we have here is at 3, -1. That's this point here. And the last point we have is at 4, looks like 4, -4. 4, -4. Okay. I'm noticing I'm going to use it kind of like I used up above, right? I plug in a -1, I get a 4. I plug in a 3, I get a 4. That's okay, right? The x's have their own unique y's. This is where the problem lies. I'm going to go with red right here. Okay. This, I plugged in the same input as up above, but I'm noticing I got 2 different outputs. A 3 turned into a 4, and the same exact 3 turned into a -1. That is not okay. This is not a function. Okay? Graphically, that's these 2 points right here. I'm going to put red. These red ones are the reason that we do not have a function. Well, what's unique about those? This line is drawn right here. On a graph, if we ever have 2 points on the same vertical line, it's called a vertical line test, okay? Then we know, and I'm going to underline that there, a vertical line, then we know right off the bat, before I even have to list all these if I don't want, it's not a function. This x is the same as this x. They're both at 3. They're both 1, 2, 3 to the right, but they clearly don't have the same y. This one is at -1, and this one is at +4. I cannot plug in a 3 and get a -1 and plug in that same 3 and get any other answer for it to be a function. We're not saying like this is incorrect and these are impossible to see. We'll see things that aren't functions. This exact one, though, is not a function. Okay. So just an example of a graph there. That's not a function, and we could check that by listing ordered pairs over here if you like that better. It says down here, again, as long as each value has a unique y value, then it is a function. If not, it's not. Pretty straightforward. We're really hammering that today. Okay. Last but not least, there's just kind of 3 or 4 different ways that we'll see. Here we have listed 4 different ways of how we can tell if something is a function or not. Okay, we're going to just walk through these briefly. Our first method is like a list, okay, which is just listing the ordered pairs, and we can easily tell. And we're actually using the same example for all 4 of these, okay? So we'll see, again, plugged in a -3, out came a -2, plugged in a -1, out came a 2, plugged in a +1, out came a 6, plugged in a 3, out came a 10. We should be able to say function. That's a function. Okay. A second way that we'll see it is a table. A table is just another way to organize these, right? Look at these. This is going here. This is going here. We're just organizing all of our x's on the left and all of our y's on the right. I can tell, hey, each of these is different, right? There's no repeated x's. So that must be a function based on what we're given, okay? Same thing happens here. We call these mapping diagrams, okay? This is like a third way you'll see it. It's almost like this table up above, but without the x and the y, and we see these ovals and arrows instead. It's saying, hey, this arrow is saying this is what was plugged in. This is my input. Hey, here's my output. This is my input. Here's my output. This is my input. Here's my output. This is my input. Here's my output. Hey, none of these lines are crossing and saying, hey, one had 2 different answers. So this should be a function. And just a quick visual example, if you see a mapping diagram and it's not a function, you would see something like this. You would see like this 3 would also have a line up here, and that'd be saying, hey, 3 was plugged in, out came a 6, and out came a 10. Hey, that's not a function. 3 can't produce 2 different outputs. But that's not what our picture originally shows. It shows something that is a function. Each one had its own unique output. So last but not least, we'll see verbal descriptions, which is like what's happening in that machine, what's happening in that function, like the behind the scenes, the in-between stuff, what's happening here, and what's happening in between this, and what's happening in between these ordered pairs, right? Here it's saying, and this actually is true for this example up above, the y value is the set of points are 4 more than twice the corresponding x values. 4 more than, which is So that'd be plus 4, right? 4 more than twice the, which is times 2, right? Times 2 plus 4. It's saying, hey, take in, put your x here, multiply it by 2, and add 4, and you'll get your y value. So here we see, I'll start with an easy number, 1, positive 1. When I put in a 1, 1 times 2 is 2, plus 4 is 6. Hey, that's what came out, 6. Does it work again? 3, when I plug a 3 in here, 3 times 2 plus 4. Well, 3 times 2 is 6. 6 plus 4 is 10. Is that what I got? Oh, that's what I got. And the same works for these ones up above. Okay, you'll just see, like, that's really the explaining, the writing out of the math. You could even see what I wrote instead. This times x, my input, which is my x, times 2 plus 4 is my y, is my y, my output. Okay, so on and so forth. The basics of a function there, use that abstract thinking with the vending machine. If I push a button, only one item should come out. I should never push that same item and get same button and get a different item out. But I can push 2 different buttons and get the same item. It might be designed that way, or it might be a popular item in there, and it goes the same for math. Hop into one of your practices. It could be a Delta Math, traditional practice error analysis, and I'll see you for lesson 26.